Good afternoon, geometry students. I'm so happy to be teaching you. I tell you, I would rather be teaching math any day than dealing with technology issues, and I hope you kind of feel the same way. We are going to do our notes for lesson 1.6 today, and as always, all you need is a piece of paper and a pencil or pen to write with, and what we're going to do at the top is just write 1.6, and the title is going to be Angle Relationships. Angle Relationships. Now, just a little hint in case you're wondering, when we do our crib sheet review in class and I say what was the main idea, you can always just tell me whatever the topic was. So when we go over the Zoom session for these notes, and when I say what was the main idea in 1.6, you can say angle relationships. So what I'm going to do in the interest of time and to streamline things for you guys is we have 6 vocabulary words. I'm just going to say the name and the description, but I'm going to have you do the name and the picture, and I will just read the description for you. It'd be way too much for you to do all the writing for the description, but go ahead and listen to the definition, and I think drawing the picture will help you to understand it. So in geometry, as you know, we've talked about how we're dealing with points, lines, and planes. We also deal with a lot of angles. And so this is kind of like one of the last major foundational concepts that we're learning in chapter 1. And sometimes what can be really important is not just the angle itself, because we already talked about the parts of that, but how 2 angles can be related to each other. So we're going to focus more on that aspect today. So we're going to talk about several kinds of pairs. The first pair is called adjacent angle. Adjacent angle. An adjacent angle pair. So like if you were sitting at the dinner table with your brother or sister, you would be sitting adjacent to them. It just means right next to. So 2 angles that lie in the same plane and have a common vertex and common side, but no common interior points are called adjacent angles. And again, don't worry about getting that definition down. The picture that you want to draw here of 2 adjacent angles, they don't have to be the same size, but they do have to have a common vertex, which we can put the point here if we want, and a common side. Those would be considered to be adjacent angles. We have 5 more. The next one is vertical angles. Now these are super important. Vertical angles are going to come up a ton this year. I would estimate we're probably going to use the word vertical angles in class, I would say at least 200 times. The good news is the picture is super easy to draw. You just draw 2 lines crossing over each other, and then perhaps on the left you can put a 1, and on the right you can put a 2. You have just drawn 2 vertical angles. I will give you the definition for it. They're 2 non-adjacent, that means not next to each other, angles formed by 2 intersecting lines. Super important for you to know, vertical angles are congruent. So in this picture here, for example, angle 1 and 2 would be vertical angles, and they would also be considered congruent. And then 3 and 4 are vertical angles, and they are congruent to each other. And I'm showing you that with those arc marks, and we can talk more about that in class. I think we've briefly mentioned it once or twice before. Okay, another vocab word, linear pair. And this is exactly what it sounds like. You can look for a clue here. In the word linear is the word line. So let me read you the formal definition, although you may have guessed it already. A linear pair is a pair of adjacent angles with non-common sides that are opposite rays. This is a very fancy way of saying they form a line. So for example, you can have angle 1 and 2, there and there. They form a line, so they are a linear pair. All right, right angles. Let's do that next. Right angles. You guys already know about right angles, but what we have not yet discussed is that if 2 lines form a right angle, then they are perpendicular lines. So the fancy definition is 2 perpendicular lines form 4 right angles We know that two lines are perpendicular if they have a box where they meet. I guess that's not too fancy. All right, I am going to say the next vocabulary word, and then I'm wondering if you might be able to guess the one after that. I think you may have learned about this before. Maybe not, we'll see. The next vocabulary is complementary angles. Complementary angles. Now, sometimes in math we use words that sound like words we would use in the English language, like to give somebody a compliment. You guys know I'm an avid motorcyclist, so of course I love it when someone comes up to me and says, nice bike. You know, that would be a compliment. But this is not the same because it's not an I after the L, it's an E, so it would be complementary angles. Two complementary angles are angles with measures that have a sum of 90 degrees. Now, sometimes we will see these two angles actually form a 90-degree angle, but they don't necessarily have to be right next to each other. As long as the two angles add up, the measures of the two angles add up to 90 degrees, they are considered complementary. Now, I'm wondering if you ever heard the next vocabulary word. I'll give you a hint. It starts with an S. It sounds a little bit like this word, but it's not complementary angles. So think back for a minute to maybe what you learned in junior high and see if you can remember an angle that would not be complementary. The answer is supplementary angles. Supplementary. So the words sound very similar, but complementary, as we just said, means adds up to 90. Supplementary angles add up to 180 degrees. So two angles with measures that have a sum of 180. Now, just like with complementary, they can be adjacent, they can be stuck together, but they don't have to be. So for example, you could have a 30-degree angle and a 150-degree angle. Those would be considered supplementary because 30 plus 150 is 180, but they don't have to be right next to each other. They don't technically have to form a line. So that's it in terms of the vocab. Now, we have a couple examples of exercises that we can do given that we have that vocabulary to kind of talk through the problem. So we're going to do some examples of problems using those kinds of angles. These notes, I hope, are not going to be as long as some of the other ones. All right. What I would like to do, I think, is 3 examples with you guys. So we'll do example number 1. I'm going to draw 2 lines here, and I'm going to label this top part of the picture 5x and the bottom part x plus 16. The first thing I kind of would like you to think about is what would I call this pair of angles here? Can you look back through the notes that we just did and guess which pair this would be considered? Look for a minute and see if you can tell me what kind of angle pair relationship is this? Hopefully you looked and said vertical angles. If you did, you're correct. These are vertical angles. And as I mentioned to you earlier, vertical angles are congruent. So we can set 5x equal to x plus 16. Then, of course, we want to use our opposite operation, so subtract x from each side, which gives us 4x equals 16, and then divide by 4 to get x equals 4. And in these directions, we're just solving for x, so you would be done. Excellent. Okay, example number 2. Example number 2. I'm going to draw another picture here. I want you to be thinking about what kind of angle pair relationship this is. And I'm putting some clues in the way I'm drawing the picture. Go ahead and take a look at this. Again, feel free to zoom in, pause, whatever you need to do to absorb this a little better. Tell me if you can guess what kind of relationship this would be. What kind of relationship is this of the ones that we just finished talking about? that would be complementary. How do I know that? That little box is telling me they add up to 90. So because these are complementary and they add up to 90, I can write 4x plus 3 plus x minus 8 equals 90. We are good to go there. Now let's combine like terms. 4x plus 1 more x is 5x, and 3 minus 8 is negative 5. Then I want to do the opposite of subtracting 5, which means I add 5. And then the opposite of multiplying by 5, which would be dividing by 5. When I do, I get that x is 19. So that is our second example. Now, I just have one more example for you guys, and then these notes will be done. I do want to tell you, if you are watching this video, I'm not just saying this, I am super proud of you. Because no one's forcing you to do this. You've made the choice to learn as much as you can and to take your learning, to take ownership of your own learning. And I am so proud of you for doing this. I really, really mean that. I can't wait to meet you in person and tell you how grateful I am. Okay, third example. Example number 3, this is our last one. One more picture here. And by the way, not only am I proud of you for doing the video, but you're going to be proud of yourself because you're going to do better after having listened to the notes than if you didn't. So good job. Okay, look at this picture right here and see if you can tell me what angle pair relationship this would be. What angle pair relationship is this of the ones that we just finished talking about? The answer would be supplementary, because these form a line, they add up to 180 degrees. So